Problem number 7, just so I can see what's going on here. We've got 4 women, 3 men, right? So n is equal to 7 altogether. And then how many ways, this is part A now. In part A, what's it say? In how many ways can the panelists be seated in a row of 7 chairs? Okay, so all we have is we have the 7 chairs, no restrictions. 1, 2, 3, 4, 5, 6, 7. I think we can put any one of those 7 people here, and then any one of the remaining 6, any one of the remaining 5, and then 4, 3, 2, 1. That turns out to be 7 factorial, which computes to 5040. Now in part B, we want to alternate these seats. So 1, 2, 3, 4, 5, 6, 7. So what if we started out like this? Maybe we could have a man in the first seat, we're thinking, and then a woman, then a man, then a woman, then a man, then a woman. But this doesn't work now, right? This doesn't work because we have only 3 men. And there's 1, 2, 3. So this combination here doesn't work, that arrangement. You cannot have a man in the first position. So if this is going to work at all, 1, 2, 3, 4, 5, 6, 7, we'll have to have a woman, a man, a woman, a man, a woman, a man, and a woman. Now we've got the 3 men, 1, 2, 3, and the 4 women, 1, 2, 3, 4. So this combination will work. Let's count them up. So in the very first position, the leftmost position, this one right here, we have to put a woman, and we have 4 from which to choose, so that's going to be a 4. Then any one of those 3 men can go here. And then in the next position, that third position, a woman again. We've already selected 1, so there's 3 women left. Then a man. Well, we've selected 1 for that second position. So out of the 3, we've selected 1. There's 2 left. And the women, we've selected 2 already out of the 4, so there's 2 left. There's 1 man left, and then 1 woman left. So we're just going to multiply those together. So I'm going to get 144 out of that. And then in part C, what we want is how many ways can the panelists be seated if there must be a man at each end? So 1, 2, 3, 4, 5, 6, 7. Need a man here, and then it doesn't matter. Any combination will go right here. So to start with, from the leftmost position, there's 3 men. Choose any one of them. And in the rightmost position, there's two men left. Choose either of those 2. Now we had 7 people to begin with. We've taken out 5. We've taken out 2, so how many are left? 5. So we could put any one of those 5 people here, then any one of the remaining 4, 3, 2, and 1. And that turns out to be 720. Now I'll do this one down here. Number 8. Here's part A. 9 factorial. We want to know how much bigger is 9 factorial than 7 factorial. So we can write 9 factorial as 9 factorial is equal to 9 times 8 times 7, but that's 7, 6, 5, 4, 3, 2, 1, right? That's 9 factorial. But look at this part right here. That's 7 factorial. This is 72 times 7 factorial. So how many times bigger is 9 factorial than 7 factorial? It says it right here. 9 factorial is 72 times as big as 72 factorial, as 7 factorial. So the answer here is 72. Now for part B, we're going to use that idea. How about n plus 2 factorial? We could write that starts at n plus 2, then it decreases by 1. N plus 2 minus 1 is n plus 1, and then n plus 1 minus 1 is n. Well, there's our n, so n factorial. So we're going to have that number right there. Okay, so that turns out to, we could write that, I guess, as n plus 2, n plus 1. That would work. Or we could even write it as n squared plus 3n plus 3.